Okay, hello. I wanted to create a little video for you guys to explain ROC AUC a little bit better because I'm not sure I did a great job in class. So let's just walk through this real quick. So here, what I've got down here on the bottom. All right, this is an example. It's very, kind of ugly here, but these are our true labels. All right, and this is the result of our model. All right, these are our predicted probabilities, and then these are going to be our labels based off those predicted probabilities. I'm not going to belittle you with this, but it is set at our default 50% threshold, right? So this is just going to be a 1, this is going to be a 0, this is going to be a 1, and this is going to be a 0. All right. So what we're going to do though is let's talk about this in the context of and I'm going to change the thresholds a little bit and show you how this works in the context of our receiver operating curve. All right, so up here on the on the y-axis, we're going to have our true positive rate, and then down here we're going to have our false positive rate. All right, so the calculations of these things are pretty simple, I think. So this is just the actual true positives over top of the actual positives, right? This is the likelihood, the total negatives, right? And then the false positives as it relates to the total potential negatives, the total zeros, all right? So really you can think of this as like a measure of the accuracy of the positive predicted class, right? So most of these are kind of oriented around that positive, right? Positive, positive. Right, so this isn't true negative rate, all right? It's not the rate with which we're predicting negatives. It's the rate with which we're inaccurately predicting positives as negatives, all right? Whew, it's a lot, but that's kind of what we're looking at. So here, remember, this middle part, all right, is essentially equal to just guessing, right? If we have a model that's sitting down here, that means we're not really learning anything, okay? The axes on this is going to go all the way up to 1. This is going to go up to 1. It's going to start at 0. This would be a perfect positive, false positive rate right here, right? That would be, right? Everything is perfectly predicted as falsely positive. And then here, this would be perfect true positive rate, all right? And the way that we kind of put dots on this, the way that we build this graph out is that we set different threshold levels, okay? So down here at the front, right, what we're essentially doing is we're starting at a threshold. I think of this as like a threshold of 100, and then we're working all the way up here to a threshold of 0, all right? And then we're just doing the calculations along the way. So with this one, all right, let's do 50%, and then we'll actually back in. What you do is you start high with the threshold and then work your way down. All right, so let's start, let's do 0.25 as well, and then we'll see where we're at from there. But so for here, like let's start out with our 0.5 calculation, okay? I'm just going to be somewhere here in the middle. All right, so this is just our standard label. So here we know that we have two. Let's do true positive first, the true positive rate, right? So up here we know we have 2 potential positives, right? So that'll be our denominator, right? And then we know that we have how many actual positives, right? So here we have 1 and 1, so it's 2 true positives, and we have 2 total positives. So yippity doo dah, we're all the way up to 1 on this marker. All right, so now let's do the false positives. All right, so what we have here is we know the n for potential negatives is 2, right? 1, 2. So we have that 2. And then how many of those were labeled incorrectly as false positive? Well, the answer is 0, right? So for this one, we get a big goose egg. So we're going to be way down here, all right? So at the 50% threshold level, essentially our dot is right here, okay? Now, keep in mind, this is a toy example. We got 4 entries, all right? There's just really not a whole lot of diversity, so we're not going to end up building like a nice curvy curve, but let's just keep that in mind, all right? So we got our 0.5, right, which equals, all right, essentially true positive rate, TPR equals 1, false positive rate equals 0. And those just end up being the X and Y labels, right? Easy enough, all right? So let's do 0.25 here. Anything above, I'll just do this over here, 0.25, right? Anything above 0.25 is going to be labeled as a 1, right? So 0.25 or greater, all right? So our first row, if we're going back here again, and we're looking at our predicted probabilities, right? At the 0.5 level, that's going to be a 1, right? Right? This is 0.4, so that's going to be a 1. That's 0.6, so that's going to be a 1. And that's 0.3, that's going to be a 1, all right? So these are our y hats, right? It's kind of our predicted labels, not the y probabilities, just the hard labels, the predicted labels. But the actual labels here are 1, 0, 1, 0. So for the true positive rate, it's going to be the same. We got 2 true positives, nailed it, right? For the false positives, what are we going to have here? Well, we had 2 potential negatives. That's the bottom. And then how many of those did we get wrong? Well, we got both of them wrong. Oh, sad. So our false positives are 2, right? These were both labeled as false incorrectly, as positives, thus being false positive. So that also equals 1. Okay? So now our dot would be like way over here. Okay, so it would be the intersection of 1 and 1. All right? So what we see that, typically as the threshold decreases, right? So as our threshold decreases, and remember we're going from 0, all the way down, or I'm sorry, from 100 down to 0, our false positive rate, all right, is going to go, it's going to go up, and then our true positive rate, right, is essentially going to stay flat, right? And that's what we saw here, right? So this was our true positive rate. It did not change, right? And this was our false positive rate. We saw it go up. Now, ideally, what will happen in a good model is as you move the threshold lower and lower and calculate these two values, the true positive rate and the false positive rate, the true positive value will increase quickly, right? And the false positive rate will not. But gradually what will happen is that the false positive rate will continue to get bigger and bigger, right? As you move this threshold lower and lower, which makes sense, right? As you think about like where our cutoff is, as we move the threshold lower, what's happening? We're increasing the number of positive predicted values, right? Of positives, all right? All right? And that would mean our false positive rate will go up. So the threshold goes lower. Threshold goes lower. Positive predictions go up. And so does our false positive rate. Right? Okay, so a lower threshold is coordinated. Associated with this increase in false positive rate, all right? So often if we don't see any change at these various levels, again, you'll have kind of like models that don't work very well. All right, I know this is a lot of scribbling, but I hope that helps. I do want to talk through, I'm just going to try and erase this if I can fastly, how area under the curve is calculated as well. So we use these rates, the false positive and true positive rates, to calculate area under the curve. That's why it kind of matches up directly with the shade. That's why people shade it and then write it in this area here. But what we use to do that is a function called the, I just want to make sure I remember it, the trapezoidal rule numeric integration. It sounds pretty fancy, but it's basically like the idea of how you calculate the area in a trapezoid, all right? So what we're going to do, and I'll show you this, is that the equation is pretty straightforward, right? It's just false positive rate, all right, at I plus 1, so that's current state plus 1 minus the current state, all right? That's going to be in parenthetical, all right? And we're going to multiply that by, you guessed it, the true positive rate of at state I plus, at state I plus the true positive rate, right, at state I plus 1. Plus 1. All right, and we're going to divide all this by 2. All right, All right, that's because we have two entries. We're going to take the average between these two things. Okay, so this looks complicated, but let me just show you an example. We're going to calculate this number at every different threshold, right? And then we're just going to sum them together. All right. So I have a version here to walk you through. I'll zoom in on this because that is super hard to read. Okay. All right, so again, what we see here is our various thresholds, okay? All right, we're just going to slowly work down the threshold just like we did over here, starting at 100 and working down. And all this is the calculation of the false positive rate at each one of these thresholds and the true positive rate at each one of these thresholds. And then the x here is actually just the false positive rate, right? So if we go back to like the, I think I can, oh, I'm just making things worse here. If we go back to this equation that I scribbled on this board, all right, what you'll see here is this false positive rate and the true positive rate, right? And that's all we're doing down here. It's just k plus k is just another way to say, you know, current state plus 1, all right? So if we walk this back, here's C2, which if we're doing this for column B, C2 would be this state, right? So we do C2 minus, I'm sorry, that would be this state would be C2 minus B2, all right? And we just do that over and over again. D2 minus C2, E2 minus C, you get it. We can do the opposite essentially for the true positive rate, or we do C3, all right, but we're adding in the previous state instead of subtracting it. Same here, all right? So you sum all this together, and then you multiply these two numbers by each other, just like as we saw up here, see? You just multiply these by each other, and then divide the sum by 2, okay? So you can see the actual calculations down here, all right? And then this represents the actual area of this particular calculation for this true positive and false positive rate. That's what it looks like. So again, not too complicated, just have to kind of understand exactly how that math is working, and that associates with our area under the curve, all right? So it kind of uses that geometric equation to be able to do that. But instead of the x's and the y's, it just uses our false positive and true positive rate numbers because that's what we use in order to generate this curve. Okay, I hope that helps. I will talk through it again on Thursday. I think actually I can come to class on Thursday, but anyway, I'll talk through it again so you guys get a sense for it, and always feel free to email me questions or, you know, we'll talk through it again, like I said, if you have any more. Okay, thanks so much. Bye.